let us see about this. What are these longitudinal cracks or longitudinal depression at different locations? So, how to take care of this? Now, I will give you an example of this longitudinal depression. How does it look like in actual slab? For a stainless steel product, we have found out a longitudinal depression. You see, yeah. So, this is a slab of AI 304 stainless steel, and we have found some depression, longitudinal depression. Why it is longitudinal? Because the direction is in the longitudinal direction, it was in the direction of the casting. And what you cannot see, first you are seeing the depression, but if you look at the section, this section, you will find that beneath this depression there are certain cracks, subsurface cracks. So, as I was telling you, the depressions most of the time they will be associated with subsurface cracks, which you may not see, because under the at the normal surface you will just see a depression, but beneath that, under that, just below that, if you look at the cross section, this section, you will find there is a trace of crack. So, if you again look at the other section here, again you will find the crack. So, it depends how long is the crack. So, you can see its trace at different locations of sections. So, now it is as I was telling you, it is AISI 304 stainless steel, and I had mentioned to you earlier that this grade, like the typical peritectic grade, has problem of depression. So, AISI 304 stainless steel, it is expected to have some depression unless proper care is taken. So, I will now tell you what care we will take or we have taken to address this problem, to reduce the intensity of this problem. There will be some depression because it is intrinsic to this particular grade. Why depression is forming? I had mentioned earlier, there are two broad categories of chemistry. Certain chemistry has a characteristic of sticking and bulging, and certain other chemistry has characteristic of depression. What is that characteristic chemistry which will give depression? Either the chromium equivalent is around 0.1 for carbon steel or low alloy steels, or for stainless steel you have AISI 304 type of grade, where the nickel equivalent by chromium equivalent is going to play an important role, because since it dictates the chemistry. So, now I will show how we have managed to control this problem. Yeah. Here what we are showing is what is the incidence of depression. That means we find out how many depressions are there, longitudinal or transverse. Let us talk about longitudinal for the time being, because I have shown you a longitudinal depression. You can have a transverse depression also, you can have deep oscillation marks also in this type of grade. But let us now concentrate on longitudinal depression along with subsurface crack. Now, why this is a problem area? Because when you will be rolling this material from slab, when you are going to a hot rolled coil, what we will find is the subsurface cracks will come to the surface, and you have lot of surface defects in the rolled product. So, the defect is basically originating from the cast slab itself, though we are finally getting a crack in the rolled product. We had depression on the cast product, under the depression, below the depression there was subsurface crack which was not visible on the slab surface itself, but after rolling this subsurface cracks will come to the surface and you have surface lamination sort of problem. So, how do we control it? Yeah, I have mentioned here that we are keeping the mold taper fixed. What is mold taper? Mold taper is done by giving certain tapering to the mold plates, slab. is basically how the slab mold is there. Unlike a bloom or billet, or a round mold which is a single piece, here you are using basically plates. So two plates for the broad surface, 2 plates for the narrow surfaces. Now as I have mentioned that because of solidification there will be some shrinkage. So at the top of the mold solidification has not yet started. So the gap between the 2 broad faces, that means 2 plates which constitute broad face, there is the distance is something say x. When you are coming down of the mold, at the mold bottom already some amount of solidification has taken place, there is a solid shell thickness, then only you can, when it is coming out of the mold it can resist, otherwise there will be breakout, there will be, the shell will snap. So there is some thickness, maybe 15 millimeter, maybe 20 millimeter, maybe 25 millimeter when it is coming out of the mold bottom. So this shell, that means solid shell, when it is forming, it will have some shrinkage. Is it okay? That shrinkage means what? It will move away from the mold wall. So the gap at the top of the mold between the 2 plates and gap at the bottom of the mold, again 2 plates, similar location at the bottom and the top if you compare. If it was x at the top, say the thickness of the slab is 200 millimeter. So for getting a final thickness of 200 millimeter you have to back calculate, and say you have set at the top of the mold, say 200 millimeter will be say about 220 millimeter. I am giving you a rough estimation. So if the top of the mold, the distance is between the 2 broad faces is 220 millimeter, at the bottom of the mold it should not be 220 millimeter, it should be something less than that. So say it is 215 millimeter. So what for we are decreasing by 5 millimeter? To accommodate the shrinkage, because if it is 220 at the top and 220 at the bottom, what is going to happen? Because of the shrinkage of the shell, there is a gap formation between the mold wall and the shell surface. So if there is a gap formation, heat transfer will be affected. We do not want that. So to compensate for the solidification shrinkage in mold, the thickness or the distance between the 2 mold plates, 2 plates which constitute mold in the broad face direction. So the distance between these 2 will be different from the top to bottom, bottom will be less. So this is called the taper. So when this taper, that means this, what I am telling you, this x minus delta x, say. So this delta x is the taper. Say from 220 I have mentioned, it has become 215. So 5 millimeter is the taper. Now that you have to express, because the mold length again is not fixed. For different casters you have different mold lengths. So this has to be, for scientific comparison, you have to express this taper in terms of the percentage. That means how much of percentage you are giving for the length of the mold, how much is the percentage. So that is what is important. So say you are giving a 0.9% or it can be 1% for this type of chemistries where you have more of shrinkage, so the taper is slightly more, and for sticker type of grades you do not want to give more taper, because more the taper, more will be the sticking. So again, as I was telling you, depending on whether it is a sticking grade or a depression grade, your casting parameters have to be identified. So taper, mold taper is one parameter which is again set or decided based on what is the solidification characteristic. If it is a depression type of grade like say 304, you give slightly higher taper, say 0.9 or 1%. If it is a sticking type of grade of stainless steel, say it is 430, which is a sticker type of grade. So then you give less amount of taper, say 0.6 or 0.7%. So what I am now telling is, let us keep the taper fixed for 304 0.9%. So what we are doing is, we are changing the nickel equivalent by chromium equivalent. What does it basically means? We are changing the chemistry of 304. 304 has a range of chemistry, it has not fixed. For any grade, you see there is a range of chemistry, like 304 will tell you chromium should be between 18% to 90%, nickel should be between say 8% to maybe 8.6 or 7%. So that means there is a range. Manganese has to be between something, other alloying elements, carbon has to be between something, nitrogen has to be within range. So all alloying elements have a range. So I have told you what is nickel equivalent. Nickel equivalent is nickel plus all austenitic stabilizing elements like carbon, nitrogen, copper. These are the elements, manganese, which are austenite stabilizers. What is chromium equivalent? Chromium equivalent to chromium plus all ferrite stabilizing elements, like maybe you have titanium, maybe you have some other ferrite stabilizing element. So when all silicon, so when you combine all these with certain coefficients, then you get nickel equivalent and chromium equivalent. Now the ratio of this, as I have mentioned many times, indicates the chemistry of the stainless steel. So what we are showing, what is this line? I had mentioned you earlier that 0.55 is the chemistry beyond which, that means more than when nickel equivalent by chromium equivalent is more than this, the peritectic reaction is starting. So that is why 0.55 has some lot of significance. It is like 0.1% for carbon steel. In the iron carbon diagram, you find the peritectic reaction starts from 0.1%. So normally that chemistry 0.1% is called the so-called peritectic grade. Though the peritectic reaction continues from 0.1 to 0.5, but around 0.1 I have mentioned, it is called so-called peritectic grade because it is prone to depression, very much prone to depression, because it is delta 2 austenite solidification is taking place around this chemistry towards in the crucial end of solidification area. So that is why this is very important, you have more of depression. Like that, like 0.1% carbon steel, 304 stainless steel is again so-called peritectic chemistry we call it, because the chemistry is near 0.55. Now see what is happening. In normal 304, what is being used? The nickel equivalent and chromium equivalent is rough, approximately in the area of 0.57 or say 0.58 to 0.56. This is the normal chemistry range of 304. So what is happening? You see, as I have told you, since it is near the peritectic zone, slightly more than the peritectic chemistry, you have lot of incidence of depression formation. Say is maybe around 40% depression. So now what is the technique? What can be done? We are keeping whatever precautions are necessary for continuous casting, that we are using. That means mold taper using slightly higher. We are using a proper powder, as I told you, to get a good heat transfer in the mold. In addition to that, what we are doing? We are slightly changing the chemistry to bring the nickel equivalent to chromium equivalent less than 0.55. It is possible because all these elements have certain ranges, as I am telling you. Nickel has a range, chromium has a range. So what we are doing? We are decreasing the nickel equivalent by chromium equivalent, basically means we are slightly decreasing nickel, we are slightly decreasing manganese, maybe we are slightly decreasing carbon, and we are slightly increasing chromium, slightly increasing silicon. In that way, everything is done within the range. You cannot go beyond the range because it has to be 304. Instead of 304, you cannot make 301. So within 304, whatever are the limits, you are trying to control the alloying elements within those limits. So what is happening? You just see, if you can bring down nickel equivalent by chromium equivalent slightly, not much, from say around 5.7 to say less than 0.54. You look at here 0.54, 0.53, 0.52. What is the incidence of depression? It is much less. It is about 10% only. Initially it was 40% or more for the normal 304 chemistry. So what has been done? Slight adjustment of chemistry has been done to bring it from above the peritectic start chemistry to less than peritectic chemistry. 0.55 I am telling you is the peritectic start chemistry. So from above 0.55 nickel equivalent by chromium equivalent, you are bringing it to less than 0.55. You make it say 0.53, 0.54, 0.52. So it is basically not much of variation in chemistry. So I can call it minor adjustment of chemistry, understanding the solidification sequence. Here what is happening, delta to gamma transformation, since it is in the peritectic region, delta to gamma is taking place in the crucial zone of end of solidification, in the crucial zone between 90% and 100% solidification. So if it takes place there, delta to gamma transformation stress is acting on it. So this stress or strain is increasing the tendency for depression. So the result is high amount of depression. If we can control the chemistry by to a minor extent within the alloy range of 304, within the chemistry range of 304, we are slightly decreasing the nickel equivalent by chromium equivalent to a value which is less than the peritectic start, which is 0.55. We are making it 0.54, 0.53, 0.52. We cannot make it very low because it will go beyond the 304 chemistry. So it has to be minor. So 304 chemistry basically is encompassed within say the range of 0.58 to 0.52 nickel equivalent by chromium. If you look at the chemistry range, you will find it is possible to adjust it within this range, not beyond. So within this range we have modified and seen for the same continuous casting parameters, keeping everything same, what is the incidence of depression. Incidence of depression can come down quite a bit just by minor control of the chemistry. So this is called minor adjustment of chemistry within the specification range of 304. What we are getting? We are getting less amount of depression. So the defect of depression in 304, which is a depression prone grade, normal chemistry will have a lot of depression. So you try to adjust it first with casting parameters, as I have told you. You adjust the taper, you adjust the powder characteristics, you adjust the mold, rather the oscillation, mold oscillation sequence of parameters, like you adjust the frequency, you adjust the amplitude. So after doing all this, also for the normal AISI 304 chemistry, you will find some amount of depression. Now if you want to control those depression, what can be done is, what we have done is basically we have done minor adjustment of chemistry. Instead of having nickel equivalent by chromium equivalent more than 0.55, this is the dividing line, we have brought it down to less than 0.55, we have brought it down to 0.54, 0.53, 0.52. So what is happening? The incidence of depression is coming down. So this is one very important strategy. I had mentioned to you several times that suitable continuous casting parameters adjusting to the solidification characteristic is very important. That is first strategy. Your casting parameters you have to adjust to suit to rather to take care of the sticking or depression characteristics. If you have a sticking tendency, your continuous casting parameters will be something. If you have a depression characteristic, that means what we are talking is different grades of steel. Some may have sticking tendency, some may have depression tendency. For those grades which have sticking tendency, your parameters, casting parameters will be something. For those grades which have a depression tendency, casting parameters will be different. As I have mentioned to you, mold tapered will be different, mold powder characteristic will be different, mold oscillation parameters will be different, secondary cooling parameters will be different, intensity of secondary cooling, distribution of secondary cooling will be different. So, speed also possibly you have to adjust it to certain extent. So, all these are casting parameters which have to be decided based on the solidification characteristic. But on top of that, I am talking about another strategy, that is minor adjustment of chemistry. With minor adjustment of chemistry, again, as I have mentioned, 304 like 0.1% carbon, the so called peritectic grade. Here what is happening? If you have nickel equivalent by chromium equivalent which is more than the peritectic chemistry of 0.55, you have some amount of depression, quite a large amount of depression rather. So, you can bring down this depression keeping all other parameters constant by controlling this nickel equivalent by chromium equivalent to less than 0.55. So, it is basically minor adjustment of chemistry. This is one important strategy. First I had talked about controlling the casting parameters depending on the type of certification, whether it is sticking or depression types. Now I am talking of another strategy which is minor adjustment of chemistry. So, by using this chemistry adjustment, we have brought down the incidence of depression in an important grade like 304. It is the most popular stainless steel grade, but it is beset with the problem of depression. You can have lot of surface depression, and surface depression is bad because under this depression you may have cracks. While you are rolling the material, those cracks will come to the surface and the final rolled product will have lot of surface cracks, and there is a high incidence of rejection because of that. So, to take care of that, to improve the quality together with optimum casting parameters, you can use minor adjustment of chemistry, this strategy also, to bring down the incidence of depression. So, I have talked about mechanical soft reduction, how does it control the central segregation and central crack. I have talked about minor adjustment of chemistry for 304 type of grade, how it can control the incidence of depression.